Now, we are going to perform some experiments on sodium and potassium. So let's start with sodium. Let's just take out a small pieces of sodium and you guys can have a look at the appearances. Now, this is a piece of sodium metal, and you see that it looks like grayish or even white in color. That's probably a very old stock of sodium. Now, we do not need to use that huge pieces of sodium. So right now I'm going to cut it into small cubes. As you can see that, it can be easily cut just like a butter. And after cutting, you can see that the cut part is showing you a silvery appearances, but then gradually it turns grayish. This is because the metal beneath has not been exposed to oxygen before, so these are the pure sodium metal. However, after cutting, the oxygen in the air reacts with the sodium within and forming the grayish sodium oxide. Now this large chunk of sodium, I will put it back to the container. Now I will further cut it into smaller pieces. Now I have prepared a large trough of water, and what I'm going to do is to add a small pieces of sodium into the water, and let's see how the sodium reacts with water. Now, after the reaction has completed, we are going to add a few drops of universal indicator into the solution. As you can see that blue color is observed, meaning that the solution is alkaline. Now, let's do this experiment again, and this time I will try to explain to you the observations as the sodium metal reacts with the water. Now, as you can see, first of all, the metal has melted into a silvery ball, right? And it is moving rapidly on the water surface, and you also hear some hissing sound. Now the reason why it melts into a silvery ball is because the reaction between sodium and water is highly exothermic. So meaning that a lot of heat is released. The heat is able to melt the metal into liquid. Now the reason why the metal is moving on the water surface is, first of all, Group 1 metal is less dense than water, so instead of sinking down to the bottom, it actually floats. Now, the reason why it travels around is because the reaction between sodium and water produces hydrogen gas. And the hydrogen gas is formed on the surface of the sodium metal, and those gas bubbles are formed unevenly on the surface of the metal, and therefore those gas bubbles push the metal in various directions. So that's why it is moving. As to why you hear the hissing sound is because the hydrogen gas bubble, once they are formed, they are quickly burst. So that hissing sound is coming from the bursting of the hydrogen gas bubble. Now lastly, as you have predicted, if I add the universal indicator, it should give us a blue color. The reason is because the reaction produces sodium hydroxide, and the sodium hydroxide dissolves in water to give you an alkaline solution. And that's why the universal indicator is blue in color, showing that the pH of the solution is way above pH 7. This one is probably pH 12 to pH 14. Now, we are going to do the similar experimental procedures, but this time we were doing it with potassium. So first of all, let me take out a small pieces of potassium metal. Now, as you can see that potassium metal appears to be a grayish solid. Again, the grayish solid is due to the formation of potassium oxide on the surface. Now, we are going to cut it into smaller cubes. Now, you see how easily I cut the potassium metal. In fact, potassium is even softer than sodium metal. And similarly, as you can see from the cut surface, it gives you a silvery luster as you freshly cut it. But then, the silvery appearances quickly tarnishes because the potassium metal underneath reacts with the oxygen quickly to form potassium oxide. So let's just have another small cube of potassium metal. And let's put the large cube back to the container. Now, we are going to add a small pieces of potassium metal into the water and see what we can observe. Now, we add a few drops of universal indicator into the solution. The solution turns blue. Now, let's watch it one more time, and this time I will give you the explanation to the observation. Now, as you can see, the reaction is much more vigorous than the sodium, but we have similar observations. First of all, the metal melts into a silvery ball, traveling rapidly on the water surface, producing hissing sound. The explanation is similar to that of the sodium. Now, as you can see, that potassium this time catch on fire, and it burns with lilac flame. The reason why it burns with a lilac flame is not because of the metal that is burning. Instead, it is the hydrogen that is being ignited. Now, for potassium, because it reacts much more vigorously with water, it releases much more heat. So the heat released is able to ignite the flammable hydrogen, and therefore it catch on fire. Now, when the fire burns together with the potassium metal, it gives us the characteristic lilac flame. And similarly, potassium reacts with water to produce potassium hydroxide. Potassium hydroxide dissolves in water to give you an alkaline solution, and therefore turning the universal indicator blue. In a real classroom demonstration, the teacher will put the screen in between the teacher and the students. The screen is used to protect the students because if the liquid splashes out, the screen can block the liquid from reaching the students. Knowing that the liquid is not only water, but it is actually a corrosive sodium hydroxide or potassium hydroxide solution. Now, I'm going to demonstrate to you the experiment of investigating the reaction between calcium and water. Now, first of all, we have a large beaker here and an inverted funnel. Here we have 3 pieces of blue tack, which in our notes they are called the plasticines. Later on, I will explain to you the purpose of the plasticine. And over here, we have a test tube filled with water. So first of all, we are going to transfer some calcium granule into the large beaker. Place the calcium granule in the center of the beaker. After that, place the plasticine into the beaker. And then put the inverted funnel on top of the calcium granule. Now, prepare yourself a large beaker of water, and what I'm going to do right now is I'm going to quickly pour the water into the apparatus and at the same time put this test tube on top of the stem of the inverted funnel. Now the reaction takes place quickly and you will be able to see a lot of gas bubble produced at the beginning. And now you also see the solution turns milky at the bottom here. Now the formation of gas bubble is due to the formation of hydrogen gas, and the milkiness of the solution is actually due to the formation of calcium hydroxide, which is slightly soluble in water. Therefore, once the solution is saturated with calcium hydroxide, the excessive calcium hydroxide will be able to form white precipitate, therefore leading to the formation of the milkiness of the solution. Just now, did you notice that there are some pumping action occurring, right? So the pumping action is due to the pressure building inside the funnel. Now, in order to minimize the pumping action, we use the plasticine to lift up the inverted funnel so that it is allowed the pressure inside the funnel to be equalized with the outside pressure. Also, lifting up the funnel allows the water to reach in to the interior of the funnel, allowing the calcium granule to react. Now, we are going to test the gas collected from the test tube using a burning spin test. A pop sound indicates the presence of hydrogen gas that is collected by the test tube, which further confirms that the reaction between calcium and water produces hydrogen gas. Now, a few drops of universal indicator is added to the reaction mixture. the solution changes from colorless to blue, showing that the solution is alkaline. And that's the end of the demonstration.